Hey, good morning. Welcome to our webinar today, everyone. So we're looking at looping in FME. Get our title, To Loop or Not to Loop, Overcoming Roadblocks with FME. So we've got 4 presenters on today. You can see all of us here. So my name is Laura. So I'm an FME server expert here at SAFE, but I've done a decent amount of work with loops on and off over the years. So it'll be fun to show off what I know so far. Let everyone else introduce themselves.
Yeah, I'm Mark. I'm the FME evangelist, and I work a lot with FME Desktop and helping our users on the FME community to make use of it.
Hi, I'm Sienna. I'm an FME server expert, and I mainly work with loops in regards to APIs, so I'm excited to show that off for you.
Hello, everyone. We're saving the best for last. That's me, Trent Kading. I'm on the desktop team, and looking forward to showing some good demos today.
Awesome. So with that, I guess we'll turn off our webcams as we get into the meat of this presentation. So here we go. All right, so on the agenda for today, so we'll first just start with some basic definitions, just getting into what looping is and how it works inside FME. And then we'll go through a series of examples and demos just to see what loops can look like in action. So we'll look at looping a set number of times, looping until a specific condition is met, looping through a list of features, as well as loops and grouping.
We should perhaps say, Laura, that everyone's welcome to enter questions at any time, and we'll do our best to answer them. We got 4 people here today, so if one's talking, the other 3 are raring to go for you. So, yeah.
Yeah, absolutely. So get those questions in if you do have anything you want to know more about loops in FME itself. Yeah, so first off, what are loops? So I think probably the closest match for a definition of a loop that I've found that kind of most closely aligns with how FME works with loops is computer programming. So basically, in that context, a loop allows for repeating the same set of code over and over again until a task is completed. So the point of that in computer programming is to avoid writing out the same lines of code many times in order to run it multiple times. So when you think about this in FME, it provides a way to avoid having to repeat the same set of transformers over and over to repeat the same process. There are 2 kind of primary types of loops that we'll look at in some of the examples coming up as well. The first type would be a for loop, and that's basically a loop where you repeat a process kind of a set or a known number of times. So an example might be trying to run a process 100 times. You want to do this X number of times. Or another example might be repeating a process once for each item in a list. So an example might be reading a CSV file. You want to repeat a process for each line in that CSV. You know how many lines are in the CSV, so you know when to stop when you get to the end. On the other hand, you have while loops, which basically involve repeating a process kind of an unknown number of times. It's usually you repeat something until a condition is met. So you would maybe run some line of processing over and over again with a slight difference in the parameters you're sending through until you match a particular condition. So if you're maybe increasing a buffer distance until that buffer overlaps with another polygon in your data set. So you'd keep going and iterating through and making that buffer larger until you hit something that you're looking for. So when it comes to FME, loops are handled within custom transformers. So we'll see this in a few of the demos coming up as well. But when you create a custom transformer, you can add what we call transformer loops into that transformer itself. So it'll look something like this. You can send features directly into that transformer loop to send those straight back to the beginning of the set of processing in your transformer. So you can send them back to be processed again. And you can change some of the variables or some of the attribute values as you go through it and continually process. One thing I'll mention, if you're not too familiar with custom transformers or you're interested in diving much deeper into how custom transformers work, we do have a webinar coming up about custom transformers themselves. So definitely mark that one in your calendar. That'll be a good one. All right. Mark, do you want to chat to this
Yeah,
one?
I mean, I think one of the key things about loops in FME is considering whether you actually really need it or not. Um, and as the quote says there, you're sometimes so preoccupied thinking whether you could that you don't stop to think whether you should. And I think what we'll show you today is that in a lot of cases you don't actually really need a loop. But hopefully, we'll show you enough that when you do really need a loop, you'll recognize that fact and you'll be able to do that. But yes, whenever you think you need a loop, have another think about it, and because quite often you don't. But we'll see that.
Yeah, awesome. Yeah, so I think one good example of this kind of comes, I've seen this question come up a few times, especially when people are kind of new to FME and kind of coming at it from maybe a bit of more of a programming mindset. I've had people ask if there's a way to kind of loop through each of the lines inside a CSV file, and for example, like create points from a lat long coordinate or do something with each of the records in there. And they're looking for a way to add a loop in FME to make that happen. And when you do this in code, you do need a loop to make it work. So in that case, you'd have some kind of a for loop, and for each line in the CSV, you would take some action. But within FME, you don't actually need to kind of think that way. Our readers and just the way that FME is designed kind of takes care of that for you. So you don't need to loop through things like files in this case. So we'll have an example here. I've got a workspace to kind of help illustrate a little bit of that to get started. This one here, Mark, I don't know if you want to kind of talk us through this a little bit.
Sure. I mean, it really is what you said. It's trying to be a graphic illustration of what you don't need to do. If you're new to FME, there's a couple of Python scripts in there. I won't say they're very good Python scripts, but they do illustrate two different ways you might read a CSV file with Python. You might read the entire file into a list and then loop through the entries in that list one by one. Or the alternative is that you read each line of the file separately and process it and loop through the file that way. So those are two ways you might read CSV in Python. But those are just examples. And in the top right, in this that red bookmark, those are sort of what it would look like if you tried to do the same thing in FME. And you really don't need to do that. You don't need to say, oh, read all the file and then put a loop in for every record, do this. And you don't need to say, do read each line of the file and do this. There's no sort of default looping in FME. The green bookmark underneath shows that you just read the file and you carry out the process you want. So we just like to reiterate that point because, as Laura said, if you come from a sort of scripting background, you might have the idea that you need to put loops inside to process every single feature that's coming through FME, and that's not the case. For the most part, FME just does that by itself. So
Yeah,
I think that's
exactly.
the point of that workspace.
Yeah. Yeah, so it'll naturally, when it reads in those files, you'll have one kind of feature come in for each of the rows, and that will trigger each of the transformers and each of the processing tools further down to happen once per record just by default. So it should
That's
happen
right.
naturally. Yeah.
Yes, and somebody mentioned in the questions that CSV Reader sends the next record down before all work is done downstream, which is true. So sometimes you just have to think a little bit more about not so much looping, but how features are read in FME and how they're passed through the different transformers. Generally, it's not really an issue, but it's worth looking up that maybe on the community about how features flow. Anyway, that was a sort of a side point, I guess.
Right, perfect. Yeah, so that'll take us to the first scenario that we'll look at, and that is creating a loop to kind of loop through something a set number of times. So do X 10 times, for example. So in this case, you probably don't even need to use a loop inside FME. So in this example here, maybe we want to generate 1,000 random points within a set area. So you could potentially use a loop for that, run it through, loop to the end every time you have a new feature, and just loop through 1,000 times and keep doing the same thing over and over again. But we also have a transformer called the cloner, which would allow you to make a set number of copies of an incoming record to process that a set number of times. So in this case, particularly if you know exactly how many records you need or how many times you need to loop through, a cloner is often a good replacement for using a true loop inside FME. So here we've got our incoming records, just one coming through. We're cloning it 1,000 times, and then we're going to run the processing 1,000 times because of that. So we've got an example here. So for this scenario, I have a data set showing information about parks. Each of those parks has a record that represents the number of trees inside each. So there was a bit of a tree census that took place. And what I'd like to do is just create a map to show a visual representation of the number of trees and kind of the density inside each park. Since I don't know exactly where every single tree is located, I'm going to take the number of trees and then just randomly add points to represent where those trees could be inside each of those polygons. The obstacle for me is it's not exactly the same number of trees in every park, so it makes it a little bit more difficult to run this with a variable number per park. So we could potentially use a loop to make this happen. So let's take a look at a workspace that can do that. So I have my workspace pre-built, so I'll just run this here. I can show my parks data. So it just shows locations of different parks here, and I have a record on each of these. There it is, showing the tree count. So I have everywhere from 1 to however many trees in each. Some of them have 0, and that's fine in this case. So I just added a tester here to get rid of all the trees that have, or all the parks that have 0 trees, just to make things a little easier. And so my first attempt here was to do this using a loop. So in order to create a loop inside FME, you do have to create a custom transformer. So that can be done simply from the canvas. You right click on anything and choose the option to create custom transformer, and that'll bring up a dialog. You give your transformer a name and add any additional information you'd like to get started. After you've created the transformer, you'll see a new tab appear in Workbench with the name of your transformer and the ability to kind of add transformers into that to build up what that transformer will do. So here at the beginning, I've just got my regular input port. That matches up with the input here. So I'm sending my polygon data into this custom transformer. So from this point, I can start creating my random location points for each of the trees. Actually, first thing I'll mention too is in here, I've added a parameter to accept the number of trees for each park. So I know how many trees I need to place inside each of my polygons. So the key pieces here for these points, it's a random number generator, a bounds extractor, random number generator, and a vertex creator. So I'm just getting the bounds of each park, generating some random locations inside each of those bounds, inside the minimum, maximum X, Y coordinates, and then creating a point inside that boundary of the park. So I can do that once, but now I need to loop around to do it another time. So I need to do it once per number of trees that I need. So in order to loop around, I need to use a loop in my transformer. So you can add a transformer loop just by right-clicking and saying insert transformer loop. What this will do is it'll allow me to loop to a different input port. So I could loop back to the original input port, or I could loop to a new port. In my case, I've looped to a new port. So some of the configuration I had to do to make this work is first I need to set up a count or an iterator to decide how many times I need to loop around for each park that comes in. So when I do that, I have my regular input port here, and I just create an attribute called my loop counter and set that to 1 for the start. Then I create my random points and send the points to the output. At the same time, I also do a test to check to see if my count is greater than or equal to the number of trees that I need for my park. If it is less than the number of trees, I need to loop around and start again and create another point. So here I have my loop, and I'm looping to a new input port. So this one's hidden. So you'll see that it isn't present in my transformer here on my canvas. It's just present inside the transformer. So I loop to that, and I can use my attribute manager here to increment my loop by 1. So I've just added 1 to my loop counter. So every time it goes around, I add another 1 to this. So I slowly go up one by one until I meet the number of trees that I need to create. So there's a lot of kind of extra logic needed in order to make sure I'm looping the correct number of times and I don't get stuck in some kind of an infinite loop situation where I'm creating an infinite number of trees in my parks. So with that, I can run that and I'll create the correct number of trees for each of my parks. I can see they're kind of scattered around where each of the parks outlines are. So that's good, but it does feel a little bit complicated for this particular scenario since it is fairly straightforward. I know exactly how many trees I need for each of my parks. So I can try this without a loop as well. So in this case here, this is all I need if I don't use a loop for this. So I'm doing the same things. I've got my bounds extractor, my random number generators, and my vertex creator. But this time, instead of using a loop to loop around, I'm actually just using a cloner. So I'm making X number of copies of each of my inputs based on the number of trees that I need. So I can run this as well and get exactly the same output. So here's probably a good case where a loop definitely works, but it isn't the most efficient way to process this data. It's much faster and cleaner to just use a cloner in this situation to do the work that I need. So there we have it, solutions to use the cloner to create all the copies of the data that I want to create a much cleaner and simpler solution for my particular workflow. So that brings us to the second demo here. I think, Mark, you're going to be taking it away for this.
Yep, I'm going to take over. Let me just make myself the presenter. Okay, so Laura showed that looping through features a set number of times. This time we're going to loop through, well, it's going to be a similar thing, but we don't really know in advance how many times we need to loop. We are going to loop the number of times according to the number of elements in the list. So the first feature might come in and have, well, let's see, what have we got there? We've got 5 entries in that list, and another feature comes in, it's only got 1 entry in. So we can't hard code the number to loop, but what we can do is we can dig that information out with the list element counter, and you can see the little workspace down below, and we'll build this later just to show you how it works. And the list element counter counts how many features or how many elements are in that features list, and then we go into the list indexer and pull out the next entry, and we have a counter in there called loop count, and we increment it by 1 every time, and we just pull out the loop count list entry, and we'll see that in a moment. But like Laura before, I'm just going to say that you don't always need to use a loop when you have a list. So what do you need? Well, obviously you need a list. It's probably going to be variable length. If it was a fixed list of 2 elements, you could just put the transformer down and hard code it. So you want to carry out a transformation on each element in that list. We can't use an existing transformer. This is, if you can use an existing transformer, then you don't need to create a loop. Like the list summer transformer will add values together that are in a list. List concatenator will join them together. List element counter, like I said, will count how many numbers there are there. You can find a minimum and maximum with the list range extractor. And then you can calculate other statistics like finding the mean value of the list by dividing the sum by the number of elements. It's pretty straightforward and very quick. So you need to have a scenario where you can't use those transformers. Also, you could say, well, if it could be done with another transformer, maybe we could explode that list. We could explode the list into separate features and then run those features with the statistics calculator with the group by, and that would be the same effect as if we just ran it on the list. We just have to put that list back together again afterwards. Or if we wanted to process 2 adjacent elements in a list, like add list elements number 2 and number 3 together, we could explode the list and then use the attribute manager with the adjacent feature attributes turned on. So there's a lot of places where you might think, oh, I've got a list, I need to loop through it, but you perhaps don't. Some scenarios though you will, and we'll just look at how you would do it. It might work well when the record in the list maybe has several parts as well. Like say you've got a list value that is itself a comma delimited string. Well, then I can see that you might want to pull out each of those one at a time and then explode it. And maybe even you would have two loops going, because you are allowed to nest one loop inside of another. And so you might process it like that. And so those couple of ways I mentioned about avoiding loops with a list, let's just have a look at those in FME. So this one is avoiding loops with a list by using the list transformers. Let me just run this very quickly. Actually, it might not run quickly because there's a fair amount of data in there. The point is, though, that we're adding data onto parcels. I'm going to stop that. It's going to take too long. We're creating polygons. We are doing an overlay, point and area overlay, and creating a list of which points fall inside which polygon. And then we want to add all the values together in that list. Well, we just use the list summer transformer. We don't need to create a loop to go through it all. Similar thing here, we can sort it and then do something with the attribute manager, or we can duplicate it. Remove duplicates from it. Again, we don't need to loop through it just to do that. So you'll get this workspace after the webinar, so you'll be able to look at this in more detail and see what it's doing and why you wouldn't need to create a loop. And this is the other example. Here, what I've got is I've got a whole bunch of soccer stadiums in the UK. And what I want to do is I want to find out the shortest route between one stadium to another. Well, I can do that with our shortest pathfinder transformer, but I need a start and an end point. So what I'm doing here is I'm trying to create a line from every stadium to every other stadium that they would have to visit. And the way I do that is not, you would think, okay, we'll take the stadium and then loop through all of the other stadiums to create that line, but I don't do that. What I do is I force it to create a list by merging every feature onto every other feature with the feature merger and say, let's create a list. And now, if we look at some of the data, so like we've got Everton there, if we look at the list, well, we can see all of the other teams. So there's Arsenal, there's Aston Villa, there's Bournemouth, and so on. This is a bit out of date now. So now we've got a list of all of the different stadiums that they have to go through and the coordinates of those stadiums. So now I can explode that list. And now I've got all of the points, the start and end points. I just need to join them together. And I've got all of the journeys now from every one point to every other point. So I didn't need to use a list in this. I didn't need to use a loop in this. I used a list, and I created that list artificially, and then I use the explode option. So that's one way that we can avoid using a loop. But we didn't come here to look at avoiding loops. We looked at how to create them. So let's have a look at an example of creating them. So what I've got is I've got some data, and I've got a record or a feature for every different block in the city of Vancouver. And each block has a whole list of parking violations and the amount it cost in fines. And we want to sum up the parking fines for every block. So in other words, we need to take a block, we need to go through the list, and we need to sum everything together. Well, fine, I could use the list summer, can't I? Well, no, because the values have a dollar character prefix. And so the list summer says, well, that's not a number, I can't add it together. It doesn't recognize it's a currency value. So what are we going to do? Well, I'm going to loop through each value in turn, remove the dollar character prefix, and then we can use a list summer the way it should be. So let me close that down and go to my workspace here. So what I've got is all of the blocks in Vancouver. So there's 1,000 block, and if you can see in the information here, that one has all of these different infractions with different values for fines. I made up the numbers, by the way. They're not really, I don't know if it would cost $35 for that infraction or not. But anyway, so we've got a whole bunch of numbers there and we want to add them together. I'm just creating a sample, which is what we'd normally do when just developing a workspace, just because it's quicker to do. So these are the 20 blocks I'm going to sample. And you can see if I run the list summer transformer on this, it's not going to give me any output. It's going to give me 0 because it says these don't look like numbers to me. So the list summer is not working for us there. So we're going to create a loop. So what are we going to do? Well, like I mentioned, the first thing we need to do is we need to count how many elements are in the list. So I can do this in here. And what I'm doing is I'm creating the workspace to process the data before I turn it into a custom transformer. So I'm going to measure the number of violations in each block, and we're going to call it, let's see, I've got some notes I'm just reading from. Let's call it violations count. There we go. So that'll tell us how many different violations occurred on every street. So between 1 and 655. We need to create a counter to count through the loop. I guess we could just keep reading the list and drop off the bottom and just check for blank values. And that would sort of be a do while loop. But we're going to do a sort of for loop like Laura did. So I'm going to put an attribute manager down. And I am going to say create a value called loop count and start at 0. And we're starting at 0 because if you notice, lists always start counting at element number 0. I think it's some sort of programmer's joke that non-programmers don't get. Like, how do you start counting at 0? But that's how it is. So so there we go. And now we want to fetch the record. So I'm going to use a list indexer. And I'm going to say fetch the first element from that list, or actually I'm going to say fetch the first loop count record from the list. So we just say fetch loop count record like so. I'm going to put an attribute trimmer down. So I'm doing all of the work outside of my custom transformer, which I'll create in a moment. So now I can say, okay, we fetch the fine, trim from the left-hand side any dollar characters, like so. And if I just run that to see what it does, okay, well, it set the loop count at 0. We fetch the 0th element. So now we've got the fines, and then we trimmed it with the attribute trimmer, and now we've got rid of the dollar. So now what I'm going to do is I'm going to put it back into the list. This is sort of the processing part. It's not, I can't type and talk at the same time. So yeah, I'm processing the data here. This has really got nothing to do with the list infrastructure, but it's very interesting how we can write back to the list during the middle of the loop. So what I'm going to do is violations list bracket at value loop count dot fine equals the value of fine which we just fixed. Let me check I've got that right. Yeah, so we're just saying the loop count entry in the list now has this fixed value, and we are going to run that just to check. And if I query this feature, the first element in that list, I don't know if you can see it here on the right hand side in the feature information window, it has the dollar removed from it. So basically we've got a functioning solution, but now we need to do that for all of the other entries. So what are we going to do? Well, we're going to put a loop down. So I need to create a custom transformer. The question is which transformers need to go inside that custom transformer? I mean, technically, if this solution is just for me, then all I need to put in there is, I don't need to put in there the setting up the loop count, I don't think. I certainly don't need to count the number of elements every time, because that's already coming through. So I could just put these transformers, I think, into there. But if I was making this as a solution to share, then really I should put all of the transformers in, because we don't want anything outside of it that the user would have to put themselves or wouldn't understand what it was doing. So I picked everything in there. I'm going to press, let's see, Control T, and we're going to call this fine summer. It's a fine summer for summing up fines. Yeah, some horrible dad jokes coming in there. So there's my input port, there's my output port, and we've got the basics of the transformer going on like this. So now, let's see. Yeah, so really, I'm just going to group these together. So this part is sort of the loop setup, and this part is the processing, and the end part is going to be the sort of loop infrastructure. Excuse me, and this sort of is going to sit between the two, I think. No, it probably goes under processing. I think we'll put it there. Okay, so we need to figure out the loop part and the until part. Where do we need to loop back to? Well, basically, we need to loop back to the processing part. The processing bit is the bit that needs to go round and round and round in the loop. It doesn't need to do the setup part every time for that same feature. So what we need to do is give it a place to loop back to, and we do that by adding a new input port. And I'm just going to call that loop start. And that's going to be the start of my loop. And then we are going to have, I'm going to right click and put a loop object in there and say loop back to the start of the loop, like so. So now you can see where our loop is. It starts here, it finishes here, and it goes and loops round and round and round the processing continuously. But now, of course, we need to say, well, when do we need to end this loop? Well, I'm going to put a tester down and say we need to carry on this loop until we've got to the point where we've read every element. In other words, we need to carry on until the loop count, number of times I've been through the loop, is equal to the count of the violations, i.e. the number of elements in that loop. And if it's not, then it's failed and it goes back through the loop. And if it has, then it's passed and it goes to the output. Now, the one more thing I've got to do is increment the loop counter, because I've not done that yet. Let's see, I'm just looking at my notes, make sure I've got this right. So I'm going to put an attribute manager down in this bit here, and I'm going to say, okay, well, we've done one loop here, so let's make sure that loop count, open the arithmetic editor, loop count is set to loop count +1, like so. And that's creating a count for me. So we go through, and if we haven't reached the end of the list, increment that, so we go to the next element in the list and then loop round again. I'm sort of waving my arms and to show you, but obviously I'm not on camera, so you can't see that. But this is what's happening. It's looping around there. The interesting thing is there are, say there's 20 elements in a loop. That means it goes from 0 to 19. So really, we have to only count up to 19. So if I put the loop count before the tester, I'd need to check if loop count equals violations -1. So the test that we're doing to actually exit this loop depends on where you put this increment for the loop. And yesterday we did a run through and I got it totally wrong, and it just carried on running forever because it never actually got to the end of the loop. I messed up. I counted before I tested, and yeah, so that's something to be aware of. So that's the loop close, we'll call it that. There we go. Oops. Okay, well, let's run that and see if it works. And what we should see is the features are coming through into the loop. And once they're in the loop, they're circling round once for every element in the feature. So if I go back to the start and look at the sample data that came through, how many records did we have for each one? If I added up that number of records there, it should be equal to the number of times that we've gone through the loop. So the sum of all of those values should add up to 1607. But basically, a feature comes in, it gets processed once, we pull out the first element in the list, we increment the counter, then it fetches the next element in the list because we've incremented the loop counter, and so on and so forth until we've got to the end. So this is like a do until loop. And if we look at the output, we should see that I can click on one of these and we can look at the list, and all of the values have been removed. The dollar signs have been removed from every value, and now the list summer should add that up properly and give us a sum. And we can even add a transformer like the number separator, and just to tidy that up a bit if we even wanted to. Not that really this is too important for loops, but we can even put the dollar on there and back on there and put a number of cents on there, and sort of that gives us an output. Or does it? Let's call it summed value. There we go, summed value. So now I just put it back into its dollar and cents equivalent. So that is basically looping through a list. You find out how many elements are in the list, then you pull out the first element in that list using a loop count attribute, and then you keep looping around through that list, pulling out the next one every time, incrementing the loop count by 1, so you're pulling out the next element and looping until you've actually got to the end of the list, which is signified by the loop count equal to violation count. And because it's outside the loop, the next feature that comes in resets those values. It resets the list count, and it resets the loop count back to 0 as well. So the next element that comes in starts from scratch and goes over again.
So now we're going to go on and talk about looping until a condition occurs. So this is typically the reason why you want to use a loop in FME. You don't know all the data ahead of time, or you're not sure how many loops that you need to run through. You want to wait until a condition occurs, and then you'll end your loop. It's one of the best reasons. However, it's one of the easiest ways you can create an infinite loop in FME. And if you do, it's not a problem. You can just watch your workspace, and if it's not running, if it's not ending when you think it should end, then you just have to manually stop it. So looping until a condition occurs, Mark did show this off, but I'll be taking a little bit of a different approach to it. But basically, you can use a tester to test to see, should I continue on and send my features to the output, or do I need to continue looping? So we'll check that out. So one of the best reasons I think to use looping is if you're using a pagination from an API. So if you're not sure what pagination is, when you're working with APIs, often they won't give you all the data at once. They're all on different pages. And this makes sense. You wouldn't want to return a huge data set through one API call, because it could be large and it could crash your workspace. So this is an example from FME Hub. You can see that we have results on different pages. We wouldn't want to return the 1,023 results all on one page, because that would be so overwhelming for users. So instead, they're broken up into different pages. And just like pagination, we have different pages and we have different results per pages. Now, I should make a note here. Looping could be avoided. Let's say the REST call returns how many pages of data there is, or let's say it returns how many records there are, and you can estimate how many pages of data there would be. Then you would not need to use a loop. You only need to use a loop if you don't know how many records there are or how many pages you need to loop through. So we can take a look at that. So in my example, I'm pulling data from FME server jobs around a certain date. So I don't want old jobs, I only want new jobs. And so there's no way for me to know how many pages of data I'm actually looking through. So to do this, I'll need to make multiple calls to the FME server REST API. To get this, I'm going to use a loop in FME to get all my results. So let's take a look at what this looks like in action. And so here's my transformer, my custom transformer that I built for this loop. And first, let's take a look at the HTTP caller. One thing that I wanted to point out, like it is written right here, but when I first started using loops with the new HTTP caller that does concurrent looping or max concurrent operations, what that means is we'll try to submit multiple records at once to try to make your workspace faster. However, this has a negative impact on looping. So this parameter has to be set to 1 if you're using looping within a custom transformer. And it's written right there, but I did miss it the first time I did try this out. What I wanted to bring your attention to is we have a limit and an offset. So the limit is how many records we're going to pull. We're pulling 100 records. And the offset is how much we want to offset from that first record. So first I'm going to pull 100 records. If I don't get all the results in those 100 records, then I'm going to start using the offset to offset to the next 100. And here in this attribute creator, I have the offset set to 0. So originally it's going to go in, the offset is set to 0, and it's going through and it's going to make the first call to get the first 100 records. I work with the dates here because I'm just wondering, is this within the right time frame? And if it passes that, then I can go on to my sampler. What my sampler is doing here is only going to get 1 out of every 100 records. So I'll get 1 out of the first 100, 1 out of the second 100. And if it does find I have a 100th record here, what it's going to do is restart that loop. And so while restarting my loop, I'm going to actually change that offset as well. So that makes it grab the next 100. And we can see this in action. It's going to run really fast, which is normally a good thing, but it's a little bad for demoing this. So rerun workspace. And we can see here, it's going to go through and it's already done it. So basically it went through, it grabbed the first 100 records, it sampled, grabbed 1 record from that, and that 1 record was able to restart the loop. And that's all I had to show off, so I'll pass this off to Trent.
Continuing on with our next demo, we're going to take a look at group by looping. Now, group by looping, it can be made use of with spatial or non-spatial data. The example that we're going to take a look at in today's demo will be spatial data. Now, a couple of questions we might get, or one of the questions we might get is why would you need to use group by looping? And there's a couple of reasons for that. One of which could be, if you wanted to perform some type of iterative analysis that doesn't require you to run the workspace multiple times through trial and error in terms of trying to determine the correct value that you want to run your workspace with, might be one example, which is kind of the example that we're going to take a look at today. The second reason might be if you want to perform some type of statistics gathering, an example of which could be if I want to check tree density. I'm going to plant X number of trees. I'm going to check, calculate the density, and then if the required density value that I'm looking for isn't hit, I'm going to continue to plant more trees in that section. And I could keep running through that loop until I find or until I reach that correct density value that I'm looking for. Now, a quick gotcha, if you will, when it comes to using group by looping or any type of blocker transformer within a loop is that as soon as you add a blocking transformer, FME will ask you to export that transformer as an FMX file, which you'll see here in the dialog on the right. Now, what this means is basically the custom transformer will no longer become be an embedded transformer, but rather a linked transformer. Now, what this means, the key difference that this represents is that you will lose the feature caching or the debugging ability that you do for traditional custom transformers. If you recall in all the other demos, which if you take a look at the workspaces afterwards, you can see the custom transformers will have an extra tab in the main workspace that you can, actually go through the custom transformer and take a look at the feature cachings and take a look at the data as it ran through the steps of that custom transformer. However, once it's been exported to an FMX file, you no longer have that option. So it does make debugging and setup a little tricky for users. Now, I will mention that I personally find it very helpful to, I'll set up my custom transformer and test it, as far as I can. And then I try to add, what's going to be the blocker transformer or, that component that's going to make it a blocking custom transformer where I will have to export it to an FMX. I try to do that as the last possible step. That way I know, the data is good up until that transformer. So I know that the problem I'm doing is something to do with that new addition with the blocking transformer. Now carrying on, the demo we're going to take a look at today is, we'll have some community centers and restaurants within downtown Vancouver, and we are going to take a look at where is the closest neighborhood to a given community center within a buffered area. And we're going to do that based on neighborhoods. So you'll see here kind of in the image that we'll have the polygons are representing the neighborhoods. The green dots or points are the restaurants, and the red pentagons are our community centers. I'm just going to step out into the workspace. So here's the workspace here. Just going to step through this briefly, and then we'll take a look at our custom transformer. So we've got our input data sets, our community centers, our neighborhoods, and our food vendors. We're just doing a little bit of data cleanup, if you will, in terms of ensuring that our data is in the correct coordinate system. That way, when we perform our buffering and our overlaying in our custom transformer, that everything matches essentially. And then on the custom transformer, I'm just going to open it up just so we can see the parameters. So you'll see I have a buffer distance here. The attribute that contains the neighborhood, and this is going to be key for our grouping by. We're going to group by the neighborhoods. That way, we're only comparing community centers and restaurants that are within the same neighborhood. And then these two parameters are kind of key ones that we'll come back to once we take a look at the custom transformer, but keep those in mind. So I'm going to run this while we take a look at the custom transformer. So I'm going to go ahead and run that and just kick that off, and we will come back to it in a few minutes. So here's our custom transformer. And as I kind of mentioned, so in a traditional custom transformer that doesn't require a FMX file, generally in your normal workspace, you would just have another tab up here that references the custom transformer, which I could open up, and then I would be able to see the contents of the custom transformer. However, because this is an FMX file, we don't have that option. So anyway, so here's the input ports from the custom transformer. So we have the restaurants and the community centers. We are going to buffer the community centers, and then we're going to overlay those on top of the restaurants. So the community centers will be overlaid, or the restaurants will be overlaid on the buffered community center. From there, we're going to do a quick test basically where we're just trying to find an overlap where a community center does have a restaurant within their overlap within that area or that buffered area. If there is a match found, we're going to carry that community center through and just pass it outside of the custom transformer. Because for this example, all we're caring about is a single match. We don't care if there's 10 restaurants. We just care as long as there is one within that given neighborhood. Now, if there isn't, we are going to increase the buffer distance by 10 and then continue through the loop. So we're going to, kind of iterate through our buffering to ensure that we find a match for each community center. Now, if we go back, so we'll notice this is still running. And I have 9 completed, but that 10th one still hasn't completed. So I'm going to go ahead and stop this. And the reason for stopping this is because that could have run indefinitely. Now, if we go back to our that custom transformer workspace, I'm just going to highlight 2 parameters that I kind of mentioned at the main workspace that are important. So that's these maximum number of iterations, and then the attribute to hold the iteration count. Now, what these do is these present basically a safeguard for looping within FME, especially when it comes to a blocking transformer. Now, what these do is basically they will allow you to add a number condition, if you will, to the loop, meaning, it will run for X number of times, and if the exit condition or, my desired condition, so in this case, if a community center has still not found a restaurant after 4 times of running through, it will just exit as incomplete. This is just a graceful way of basically ending the loop, as opposed to how you saw me end it there in the workspace where I had to just manually stop it. So these, highly recommend making use of these parameters when using any type of group by looping or blocker looping, or just looping in general, where you're not sure if the condition will ever be met. Now, the reason that condition would never be met is if we take a look at our data. So here's kind of a completed run of our data. So we've got the little green dots or points are our restaurants. The red pentagons are our community centers. We've got the neighborhoods in the background, the polygons. And then you'll notice we've got two different circles, if you will, here. So we've got the blue one here, and then we've got the kind of the, I guess, magenta or pink ones here. Now the pink ones are referencing community centers that did find a restaurant within their buffered area. Now if I take a look at, if I select one of these, and then I can just take a look over here, and we'll see the buffer distance. So you can see the buffer distance increased based on, which feature I'm going to select, which is kind of, what we expected. However, the reason this one didn't get one, this one here, is because we actually don't have any restaurants within the same buffered area. Now you might be asking, when you look at this, oh, well, hey, what about this guy here? Well, the reason this guy's not found a match is because they're not within the same neighborhood. So again, remember, we were going off the neighborhood. So we were only looking for restaurants that are within this polygon here. And as you can see, there are none. So that's why that using that maximum iteration count can be quite vital. Because if I run this workspace again, we'll just do it with, I believe, 10 works. We should get 9 completed coming out, and we'll have 1 completed out of the incomplete port. And we'll have 9 completed, but if we go back, we have 9 completed and 1 incompleted. So that's just a graceful way of exiting the loop. Now, if we dive back into our slides, so, that's kind of sums up the demo. So, the goal was to find the closest restaurant from community centers based on the neighborhood. Now, the obstacles were, I could have just sat here and manually input a buffer distance and try to, you know, find which buffered area would find each of the community centers with a restaurant. However, I didn't want to sit here and do that. I could think of better things I could do with my time. So in that case, I can set up a loop where it just will iterate through a buffered area based on some arithmetic function. In this case, I was increasing it by 10 each time. And that way, I've added, you know, the condition that it will meet, it will loop through, and then if no match is found after X number, in my case 10 iterations, it will just exit the loop gracefully. This, you know, the result really is just a workspace that can be run without requiring you to run it manually through trial and error to get the right buffer value. Now, you know, to summarize kind of this webinar, so FME isn't a naturally a looping tool. It's not bad. That's not to say it's bad to use looping, but oftentimes a non-looping solution is quicker and easier to create and will just perform better. Because kind of a gotcha when it comes to looping is that if you're aware of bulk mode within FME, loops do not make use of bulk mode. Now, if you are going to attempt to use looping within FME, we do kind of recommend or recommend or suggest to try to avoid blocking transformers and to include logic to avoid infinite loops. If you do encounter an infinite loop, you know, that'll just run indefinitely until either FME crashes, your computer crashes, or you manually stop it. So, you know, trying to make use of those parameters I showed off can, you know, be very helpful in terms of preventing any type of infinite loop. Now, if you're looking at some real-world examples, there are a number of items on the FME Hub that make use of loops. Here's an example of a couple of those. You could definitely, you know, head on over to the FME Hub and take a look at those to see, you know, exactly how those accomplish what they're trying to achieve, or, you know, you could use those as a starting point and to get yourself some ideas. Now, a not so real-world example is this challenge we ran last year for the 12 days of FME, and this has to do with a malfunctioning robot having to navigate through Santa's warehouse to locate a package. Now, this was done by using a loop to see, okay, you know, where in the maze is the robot? Is it, you know, can it move left? If it can't move left, run back through and we'll move right, and so forth. So, you know, that's kind of a very interesting way to use a loop that you could definitely take a look at. Now, in terms of some resources, we've got a number of resources here from the documentation that reference custom transformers with looping, as well as looping with blocking transformers. We do have an older desktop advanced course that I don't believe we run anymore, actually, that has a looping example in it. That's still an excellent resource, so I highly recommend, you know, taking a look at that if you're curious about looping. And as well as feel free to sign up for the FME Academy. You can register for free over at safe.com/academy. This link here will take you there. And then thank you everyone for attending. Feel free, please stay in the loop about all things FME at safe.com/community, and have a great day.